We use the internet every single day, but have you ever stopped to think about what it is? We throw around terms like the cloud or going online like it's some kind of magic, abstract space. Well, today we're going to pull back that digital curtain and show you the internet for what it really is, a massive, tangible, physical thing.
And this quote just perfectly captures that moment of surprise. We imagine the internet as some colossal, futuristic superstructure, but the reality? The entire data flow between, say, North America and Europe is often humming through a cable no thicker than a garden hose, just lying there on the dark, silent floor of the ocean. It's pretty wild.
So let's get this straight. The internet isn't one single thing. It's a network of networks. It's a physical system where a bunch of different technologies have to work together in perfect harmony. So think of it less like a cloud and more like a global symphony, with fiber optic cables, wireless radio waves, and constellations of satellites all playing their essential parts.
Okay, but how does something like a photo actually travel through this symphony? Well, it's all thanks to a process called packet switching. When you send a selfie, your phone doesn't just beam the whole picture at once. No, it chops it up into thousands of tiny little packets. Each packet is kind of like a digital envelope with the destination address stamped on it. They might all take different routes to get there, but they're perfectly reassembled on the other end. And if one gets lost, the system just goes, hey, can you resend packet number 4? Simple as that.
Okay, so let's dive into the first and, honestly, the most important instrument in this whole orchestra, the physical backbone that carries almost all of our data. Now, forget everything you might think about satellites handling all the traffic. Get this, a staggering 99% of all international data travels through massive undersea fiber optic cables. This is the real internet.
These things aren't just cables. They are the internet's global superhighways. We're talking about huge ships that spend months at a time slowly laying them across the deepest parts of our oceans. And inside these tough, armored casings are strands of pure glass, each as thin as a human hair, carrying our data as tiny pulses of laser light. The capacity is it's mind-boggling. A single pair of these fibers can carry over 25,000 HD movies all at the same time. This is the foundation of everything we do online.
All right, so we've got these massive global highways, but how do we get on them? Let's take a look at how our own devices actually connect to this whole thing.
It's a pretty simple analogy. If fiber is the huge interstate highway system that connects all the cities, then wireless tech, like your Wi-Fi and 5G, are the local roads that get you from your house to the on-ramp. One provides that enormous capacity for the whole system to work, while the other gives us, the users, that crucial mobility and everyday access we can't live without.
You'll hear this term thrown around a lot, the last mile. It's literally just that final connection. It's how your phone talks to a local cell tower or how your laptop connects to your Wi-Fi router. These devices are all using radio waves to bridge that final gap, translating signals back into those pulses of light that can then jump onto the massive physical fiber network.
But what about places where you just can't lay fiber or build cell towers? Think about the middle of the ocean, or a disaster zone, or deep and rural Siberia. Well, this is where our third instrument comes into play.
Now, this is a super important point. Satellites aren't here to replace the fiber backbone. They're a complementary technology. They add this absolutely vital layer of universal coverage. They're designed to fill in the gaps where cables can't possibly reach and to provide a resilient backup when all the infrastructure on the ground fails.
The really big innovation happening right now is all about the orbit. See, traditional satellites are way up there, about 36,000 kilometers away. That creates a really noticeable signal delay, or latency, which is why old-school satellite internet felt so slow. But these new constellations, like Starlink, they put thousands of satellites in low Earth orbit, just 500 kilometers up. This drastically cuts down the signal's travel time, making it fast enough for real-time stuff like video calls and online gaming.
So you might be wondering, if these LEO satellites are just racing across the sky, how on Earth does a little dish on the ground keep a stable connection? Well, the key is some pretty cool tech called a phased array antenna. It can steer its signal beam electronically, so the dish itself doesn't move at all, but it can switch its connection from one satellite to the next in microseconds. It creates this totally seamless, continuous link.
So we've got the capacity from fiber, we've got the mobility from wireless, and we've got the coverage from satellites. Let's put it all together and see what the future of our physical internet really looks like.
And the key here, the really big takeaway, is interoperability. These technologies are not in a battle to become the one true internet.
Instead, they're forming a single, resilient, global system where each one plays to its own strengths. Fiber is the workhorse, wireless connects you and me, and satellite is the ultimate safety net.
So who conducts this whole symphony? Well, increasingly, it's intelligent software. Technologies like software-defined networking are basically like an air traffic control system for your data. They let network managers control traffic flow with incredible precision, and they can instantly reroute your data from a congested fiber line over a 5G network and even up to a satellite if they need to, always finding the fastest and most reliable path.
This all sounds amazing, right? But this incredibly complex, interconnected system is becoming absolutely essential to our lives. And that brings up some really tough questions about power, about access, and about control.
You see, building this physical internet is one thing, but making sure it's fair is a whole other challenge. The digital divide is still a massive problem. Billions of people still don't have reliable access. And control over these physical cables and satellites, it's concentrated in the hands of just a few giant companies and governments, which raises serious concerns about censorship. And of course, the more connected we all are, the more vulnerable we become to widespread disruptions, from cyber attacks to just plain physical damage.
So as we continue to build out this magnificent physical global machine, this is the question we absolutely have to ask ourselves. We are engineering a nervous system for the entire planet. Is it going to be one that empowers everyone equally, or will it be one that just tightens the grip of those who are already in power? The answer to that isn't in the technology itself, but in the choices we make about how we build it and how we govern it.